Good day to everyone. Today we are doing grade 10 Euclidean Geometry. So we will be looking at properties of quadrilaterals. Mainly there are a lot of quadrilaterals that we're going to mention. It's not only these three. We have some more that we're going to add. We're going to do some questions, understand how to prove in this video. So make sure that you watch the video up until the end in order to understand Euclidean geometry. So I have three diagrams on the board. These diagrams are called quadrilaterals. What is a quadrilateral? It's a four-sided shape. So if your shape has four sides, then we call it a quad. Quad means four, and then trilateral. So now I want us to discuss this shape and this shape and this shape. So we're going to start with this one. So if we check a parallelogram has the following. As you can see, there are a lot of indicators on the diagram. It's showing us what is equal to what and which one is opposite to which one, like everything. So we have to analyze this shape right now with the given indicators. So if you check carefully, let's start with number one, how to identify a parallelogram. A parallelogram, you will see it as if like it's skewed a bit. It's like a rectangle, but it's skewed. It's not straight like this one. It's a bit skewed. It's like this. I wish I had a box to demonstrate for you so you can see what I'm talking about. So as you can see, it's a bit skewed. Then now let's break down the parallelogram, the information, everything. The things that we are going to write here, you must know them by head and heart, because this will help you to answer questions in the exam question paper. So let's start with this one. So as you can see, each and every indicator, let's write the indicators here. So we have this one, number one, it's this one, and this one we have two angle brackets, which are this one, and we have two lines, we have three lines, and then we have these things, angles, these ones. So now I want us to know how to identify why did they put them there. Number one, the reason why they've placed these things is to show you that these things are equal. So let's say maybe they have placed them in three places. That means those three things are equal. For example, let's use this diagram. As you can see, we have number one, this angle bracket, which is only one. That means you have to look for another place where they've placed the angle bracket, which is here. So meaning this line, and this line, they are equal. They've shown you with what? With this thing. So how do you write it? You're going to say AD, sorry. Remember, a side, you can't write only A, because the minute you write A, it's an angle. So you have to write two letters from the starting point to the end point. Where does your line start? It starts from A. Where does it end? At D. So meaning line AD is equal to line BC. So you're going to say AD equals to BC. We are just taking out everything here. So what else do we know? We know that since they are like this, it also shows us they are parallel. So meaning AB is parallel to BC. Remember that parallel lines are equal. Another thing, we come to these two angle brackets. We're going to check, here are our angle brackets. So we're going to check where did they place the two angle brackets. This is where they've placed the two angle brackets. So meaning that this line and that line, they are equal. So meaning DC is equal to AB. Remember, what did I say about writing two letters? You're going to be like DC or CD, whatever, however you write it, it's going to be correct as long as you use the correct letters. So and then we come to AB. Then also they are parallel to each other. So AB is parallel to, why did I write AB here? It's AD. AB is parallel to DC. We know that they are parallel since they are equal. After now, we come and say, we all know how to use parallel lines. Remember, what do you know about parallel lines? It must have a transversal line. So in this case, our transversal lines, there are two of them. It's 1 and 2. And how do you work with parallel lines? You know that if there's parallel lines and a transversal, there's a Z, meaning that this angle is equal to this angle, and then there's a F, meaning this angle is equal to this angle. There's a U, which means this angle and this angle, they add up to 180. So you must have that knowledge of fun. You must have this knowledge of fun, saying that this angle is equal to this, corresponding angles, this one and this one, co-interior angles, and this one are equal. So let's try to apply this here. Since there's no long line going out of the shape, we can't use the F. But here, we don't want this one for now, so we have to use the Z. How do we use the Z? We're going to say, since we said AD is parallel to BC, that means our Z is going to go like this. And this will show us that this angle here is equal to this angle here. So meaning angle D1, whenever you're writing an angle, make sure you indicate which D, because there are two D's here. It's D1 and D2. So you have to tell us which D you are talking about mainly. So it's D1, and also put this tiny cap on top of the letter. So it's D1 is equal to B1. This angle, remember, we are not proving this thing, we're just identifying and teaching you how to use a parallelogram. So there's no need to write the reasons right now, because I was supposed to write everything down. I want us to write bit by bit and understand where it comes from. So it's alternate angles, but we don't have to write the reason in this case. But when you're answering questions, you have to. All right, and then in another way, we can take a Z like this. Can you see the Z? The Z is like this, meaning A1 is equal to C2. So A1 is equal to C2, angle C2. Remember, we are using alternate. So since we are done with these two parallel lines, let's come to these two parallel lines. Same thing, you use the Z. The Z, can you see it's like this right now? So you use the what? The Z. Use your Z like this and be like, okay, A2, so angle A2, which is this one, is equal to C1. Angle C1. Alternate angles every time. These things I'm writing every time. So let's say in future they're saying calculate X. So you know what is the value of, and here they said it's 20, and then they say find the value of X. You use alternate, and then you'll be like, okay, X is 20. Okay, and then after we are not done, we look at the opposite Z, which is like this. So it's going to be B2 and D2. So B2 and D2, alternate angles. And then we're almost done. Okay, it's AD parallel to BC, and then DC or AB, whatever. It's one and the same thing. So we're not done writing everything. These are your properties. You have to know these things. And then we come to the next thing, which is, can you see the brackets which are like this? These two, 1, 2. They're showing you that the whole of this angle is equal to the whole of this angle. So meaning angle A is equal to angle C. There's another way to write this. You can say BAD is equal to DC, but it's one and the same thing. So angle A is equal to angle C. If you were to write the reason, this is opposite angles of a parallelogram, but As I said, for now we are not writing reasons. And then we come to this one. This angle is equal to this angle. So D is equal to B. And then we are not done. There are a lot of things here we are going to write, but we are almost done. So now, can you see also 3 lines? 1, 2, 3. It's E, C, and AE, meaning AE and EC, they are equal. So AE is equal to EC. It's a side. And then we come to the next one, which has 2 lines. 2 lines, okay, so it's BE and ED. So meaning BE is equal to ED. And then we are done identifying everything in the diagram. I don't know if I have left anything. No, I didn't leave anything. So make sure you know these things, these properties. Practice them, practice, practice. And then you can now start applying these things on the questions, because if you don't know these things by head, it will be difficult for you to solve mathematical questions, because if you don't understand which one is equal to which one and everything. So you have to know this, grade 10s. Okay, let's move to the next one, which is a rectangle. So a rectangle, we know that it has what? We're going to use the same way, same procedure we use this side. We're going to check at the indicators. Number 1, we have an angle bracket, we have a line, we have 3 lines, we have this box. Can you see the box? And then what else? Okay, that's all. So now we have to identify all of them. What are they there for? So let's start with this one. This one, it's here and here. It means that AD is equal to BC. Can you see? They are showing you that since we put these 2 here, it means this one and this one, they are equal. So you write them that way. You say A to D is equal to B to C. Come to the next one, which are these lines, which is, it's here and here. Same way, you know, okay, that means AB is equal to DC. Can you see? After we come to these 3 lines, meaning they are here, 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 and here. That means all 4 sides are equal. Okay, so number 1 is BE. The same BE is equal to AE is equal to ED is equal to EC. Why? Because they've shown me with these lines to say, oh, this one and this one and this one and this one, they are equal. All of them, they are equal. So meaning if it's 5 here, it's 5 here, it's 5 here, it's 5 here. Okay, the last one is this one. Every time in maths when you see something like this, it's a 90 degrees. So meaning B equals to 90 degrees. Angle A, okay, let's write it like this. Angle A equals to angle B equals to angle C equals to angle D equals to 90 degrees. When I write it like this, I'm meaning that all of these angles are equal to 90 degrees. Then now we come to the special things now. Since we said these sides are equal, we can therefore say AD is parallel to BC and say AB is parallel to DC. Then we can use alternate also here. Let's check our alternate. Check for Z. This is my Z. Can you see the Z? The Z is from here going until here, and then that means this angle and this angle are equal. So D1 is equal to D2. And then I'm making a mistake. So it's D1 and B2. Then we check another triangle which is facing this side. So we move from here, going there until, so A1 and C2. So A1 is equal to C2. Can you see what I'm doing? Then we are done with this one. We come to this one, we check. Since they said AB and DC, meaning I must look at it like this and be like, okay, this is my Z. So A2 is equal. I said this is my Z, so it's C1. After you come to flip it and be like Z, like this Z. Oh, I already did that one. This one. Okay, now we're going like this. So it's B1 is equal to, remember the Z is like this, is equal to D2. And then we are done. We are done. Everything, we did everything about what? A rectangle. So you have to know these things, but we're going to try some questions. Don't be afraid that I don't understand what's happening now. When I just make sure you know these things and be like, okay, this side is equal to this side is equal to this side, and then you'll be fine and know how to use alternate angles. Okay, let's come to the rhombus. So the rhombus, a rhombus also same thing. We're going to point out the indicators. So we have these, we have these, we have these, and we have dots, and then that's all. So how does it work? Number one, the angle bracket. So okay, I see an angle bracket, that means AD is equals to BC, because why? They've shown me with this thing. After we come to the next one, which is these two. Okay, this, I forgot to write E. This and this, they are the same. Okay, so BE is equal to ED. Why? They've showed me with this thing. After we come to these, okay, it's here and here, meaning that AB is equals to CD. Can you see? After we come to the last one, oh, not the last one, these three, okay, here and here, meaning that AE is equals to EC. Why? They've shown me with this. You don't have to calculate, you don't have to do anything. They are telling you using these signs. And then the dot, since it's not on top of a line, it's here. That means it's an angle. So meaning when they're showing us this, meaning those angles are equal. How did they become equal? Use alternate angles you see. Let me write something here to make it simple. So since we said AD is equal to BC, meaning that they are parallel also. And then also here BE, okay, they can't be parallel because it's a diagonal line. Only these are parallel. So AB is parallel to CD. Then now, we know that since they are parallel, there must be an alternate. Parallel, there must be an alternate. So let's move with this one. So this is my Z. Can you see they've already shown me that, okay, this angle is equal to this angle, meaning D1 is equal to B1. Why alternate? You can see they've shown you. And then another way, it's this Z. This Z, can you see this Z? So it's, you write it like this, it's D2 is equal to B2. And then you are done. You know how to prove a rhombus, parallelogram, which is a rhombus. So if you know how to do this one, you'll be safe. So let me add some more, which is a kite, trapezium, and a square. I think they are the ones which are left, and then we move straight to the questions so that you guys can understand. Make sure you understand the properties. If you don't understand the properties, it's going to be a challenge for you. Let's look at these the last three shapes for quadrilaterals. So my shapes are not drawn to scale, so don't be like, is that a square, is that a trapezium? My shapes are not drawn to scale. Okay, so now let's start with a square. As you can see, it's a square. We all know from primary that a square has all the sides are equal. This side is equal to this side. That's the first thing we know about a square. So now, since we are getting more advanced, they have indicated a lot of properties on the square. It's no longer about all four sides are equal only. Now we have 90 degrees, bisecting, and everything. So let's start with the indicators. Remember that every time we start with an indicator. So the indicator, okay, let's take them out, all of them. Okay, so we have, it's not a lot for now, it's not a lot. So now let's start with the first one. So these two lines, where are they? Here and here. And then that means that AD is equal to BC. I know someone will be like, but all sides are equal. No, I get it. This time you have to write it differently, because now, can you see here where can you see, okay, let me do this. Where can you see an indicator that shows that all of these lines are equal? Here, 1, 2, 3, 4. These ones are for something else, which are meaning parallel. This shows us that AD is parallel to BC. Let me write it like this so I don't confuse anyone. Okay, let's move to this. This shows me that, okay, this, and this, and this are equal. So meaning angle AB is equal to angle AD is equal to DC is equal to BC. They are all equal. Like from grade 1 or 6, I don't know. Meaning all four sides are equal. That is why I wrote it like this. So meaning if it's 5 here, it's 5, it's 5, it's 5. If it's 10, it's 10, it's 10, it's 10. Then we move to the next indicator, which is these two lines. Where are they? Here and here and here and here. Same thing. Four sides. So meaning that AE is equal to EC is also equals to BE, also equals to ED. They are equal, all of them. After, what's the next thing? I said when you see something like a box, that's a 90 degrees. So meaning that angle B is equal to 90 degrees. There's something first I want to add. When you see a 45 degrees there, don't be like, what's happening and everything. Because now, there's a 90 degrees, but now if you check, it's 45, 45. Why? They have split the 90 degrees into two. Meaning they said 90 divided by 2. They shared the 90 degrees. It made 45 and 45. If you add them both, they will give you 90 degrees. So, in this case, we won't write, what do you call? Oh, let me write E1, A2, A1, A2, C1, C2, D1, D2. Now, how do we write it? We don't write the 90 degrees. I know I said the box indicates what a 90 degrees, but in this case, they have shown you the value of each and every angle. So that means that if you see 45, 45, 45 everywhere, that means those things are equal. So let's take them all and write them here and then say equals to 45. So what's the first one? Let's start alphabetically. So it's A. Okay, A1, it's 45. And then A2 also, it's 45. And then B1, it's 45. B2 is 45. Okay, C1, 45. C2, 45. And then D1, 45. D2, 45. After you say equals to 45. By writing it like this, you're showing that all of them, they are equal to 45. Not when you add them. All of them, they are 45. After, okay, let's move. Because these diagonal lines, they bisect A, B, C and A, D, C. They are bisecting these diagonals. That is why it's cut into half. Which comes to our next answer, which is E1 is what? Is equals to 90 degrees. This one is the one which you can write 90 degrees because can you see the box? all of them is not only E1, also here it's 90, it's 90, it's 90. What's the reason for here? Since BD is perpendicular to AC, so BD is perpendicular to what? To AC. So BD is perpendicular to AC. When they talk about bisecting, just know there's something which is perpendicular there, meaning there's a cutting in half, there's a 90 degrees. Yeah, you have to know that. So you know a straight line is equal to 180 degrees. So when they cut it into half, it's 90, 90. So that's what they did here. I think that's all, but not okay. Yeah, that's all for now. Let's say AB. Let's add this one. AB is also parallel to. Actually, I was supposed to write it here. It's AD is parallel to BC, and also AB is parallel to CD. These two, their answers, they're indicated by these things. Okay, let's move to the trapezium. This one is simple. A trapezium, you have to get the marks. When you see a question that has a trapezium, it's a simple and straightforward question. Okay, you can also see there's only one indicator. It shows you that there's no too much work here. So these indicators, they are showing you parallel lines. So meaning AD is parallel to CB. Number one. Where did you see by these things? So if you see these things, they are telling you they are parallel. So okay, since they're saying they are parallel, let's do the alternate. Every time when you hear parallel, think of Z, think of F, think of U. So let's use the Z. Our Z is going to go like this. You know how to do a Z. Then in your Z, this angle and this angle are equal. So if we check our Z here, our Z is this and this. So meaning D1 is equals to B2. Can you see? Then we flip the shape. We'll be like, okay, from here to here it's another Z. So this angle and this angle. So meaning A2 is equal to C2. They're equal, those angles. Then, okay, then you're done. There's nothing hectic about this. There's no other Z. Someone will try to do this Z. No, they're not parallel, these two. So you can't use, what do you call? You can't use the alternate thing. You can't use it there. This is the only information about a trapezium. So, let's move to the next diagram, which is, no man, it's AD here, not B. Made a mistake, sorry. Someone there is saying, here we are learning wrong things. It's AD. I made a mistake. It's AD, this line, not this line. Okay, let's come to this one, which is a kite. Kite has a lot. As you can see, let's take out our indicators. We have 1, we have star, we have 3 lines, we have this, we have 2 lines, we have a box. And you see there are a lot. So let's start with this. So these dots, they're showing that, A1, 2, B1, B2, 1, 2, 1, 2. So these are showing you that those two angles are equal. The way we are doing things, there's nothing changing. Okay, let me go to these dark dots. So it's here and here, meaning that A1 is equal to A2. Why? I didn't do anything. Here and here. Can you see? They've given me, it's this one and this one. Okay, next thing, the stars. Okay, here are my 2 stars. That means where is my first star? It's at C1. So C1 is equal to C2. You are not doing anything here. You're just taking something and writing it there. And then 3 lines. Okay, where are my 3 lines? It's here and here. Meaning that BC, KBC is equal to CD. CD. You are not doing anything. You're not calculating. You are just taking out things. And then we have this angle thing, which is here and here. meaning that this angle B and this angle D, they are equal. Okay, B is equal to D, because why? They gave me these things. All right, next we have these two lines. Where are they? Here and here, meaning that BE, okay, BE is equal to ED. What's left? This. So E1, all of them, E1 and E2, E3 and E4, they are 90 degrees. So but you're going to use E1 only. Okay, let me use them all. E2, E3 and then E4. Remember, they are angles, they are equals to 90 degrees. Another thing I want to warn you about is that it's not going to be E always. They're going to change their numbering. Maybe they'll say F. So when I just know in this position, it's 90 degrees. And then what do you forgot this? So it's this one and this one which are left. We forgot to indicate it here. So this one and this one, they're equal. So AP, so AP is equal to 80. Then you're done. And then also, since there's a 90 degrees, that means that this thing, this line and this line, they are perpendicular to each other. So AC is perpendicular to BD. That's another one which I almost left out. Get some questions. So we have a question here. Let's start with this one and then come to this one. So this is how the question they're going to ask it. So as you can see, firstly you have a diagram, have a pencil or a highlighter or a crayon or whatever. Then first thing, read the statement, step number 1, if you want to get total in Euclidean geometry. Understand it, and then it's saying determine the sizes of the interior angles of parallelogram. This, they are telling you something, that this is a parallelogram. You highlight. Then if they're saying that this is a parallelogram, you know what you have to do. You know the properties of a parallelogram. Then this and this are parallel, and this are parallel. You indicate them for yourself. They didn't put them to test you that do you understand how to use a parallelogram. And remember, in a parallelogram we said this and this are equal, this and this are equal, meaning they are parallel to each other. So now we have to find the sizes of this, of all angles. When they say sizes, they meaning all of them. They didn't specify for A and D. When they say sizes, meaning all of them, you have to find for all of them. So now, how can we find these angles? Which thing can we use? You have to think critically in this case. You know, I said every time when you see parallel lines, think of what? Number 1, F, U, N. Parallel lines. They must show you this thing. You must have it in heart, in Euclidean. You must know it by heart. So the F, I don't see any F there. So meaning that this one, it can't work. But the U, I see it. So meaning these two angles, they have to make up what? 180. But can you see that my U is like upside down? It's like this. There are angles here, and these are parallel lines. So meaning I have to add these two. So we're going to take this. So we're going to say 2x minus 30 degrees plus 2x plus 10 degrees. What I did, I added this and this. Remember that this angle and this angle, when you add them together, they must give you what? 180 degrees. Reason is corresponding angles. Okay, can I write it here? Corresponding angles. Why? You must write what is parallel to what, and say AB parallel to CD. Then you simplify. 2 plus 2 is 4x, and then minus 30 plus 10 it's plus 20 degrees equals to 180 degrees. And then 4x equals to, we take the 20, it comes this side, so it's 180 minus 20 is going to be 160. Divide by 4, divide by 4. X equals to 40 degrees. This is your x, not the angle. It's not the angle, it's your x. How do you find the angle? You're going to take this and say 2 open bracket, substitute x and say minus 30 degrees, then find the answer. But you have to write that a angle BAD, so BAD. So this angle, for us to find it, okay, can I erase here and write everything properly so you guys don't get confused? So let's start doing it. As I said, we're going to add these and say 2x minus 30 degrees plus 2x plus 10 degrees. They are equals to 180. Where does the 180 come from? Co-interior. And remember that time I said corresponding. It's co-interior, not corresponding. So it's co-interior angles. Then you show us which lines are parallel. So it's AB. So AB parallel to CD. After we say 2 plus 2, it's 4x. And then minus 30 plus 10, it's plus 20 degrees equals to 180 degrees. We take this 20 this side, it's going to be 4x, it's going to be left alone, so it's 180 degrees minus 20 degrees. 4x, and then you find the answer is going to be 160. For us to get x, we have to divide both sides by 4. This cancel this, and then we're left with x. So 160 divided by 4 is 40 degrees. This is your x, as I said. You have found your x, not the angle. Because why? Remember, your x is here. You have to find the sum for this by substituting what? The 40 degrees. So let me erase so I can write properly. I hope everyone understands that. If you don't understand, please comment and tell me that where you don't understand so I can clarify it thoroughly. So let's come to this one. So it's BAD. BAD. Why am I writing it like this? To show which angle specifically. So this angle here, it's 2x minus 30 degrees. This is not an actual angle, it's an estimation. So now, since we've found our 40, we know that BAD, it will be 2 times 40 degrees minus 30 degrees. So our BAD is equals to 2 times 40 is 80. And then 80 minus 30 is 50 degrees. So the angle for here, it's 50 degrees. And remember, the properties of a parallelogram says this angle and this angle are equal. So angle A is equal to angle C equals to 50 degrees. Reason opposite angles of a parallelogram. And then now we have to find this one. This one will help us to know this one. So same thing. You can say angle D or you can say CDA. So it's CDA. I prefer it like this. And then CDA, you'll be like, okay, it's 2x plus 10. Estimation again. 2x plus 10. And then you say CDA equals to 2 open bracket 40 degrees plus 10 degrees. The 40 comes from x. Remember, wherever there's x, I put 40. 2 times 40 is 80. 80 plus 10 is 90 degrees. So meaning here it's 90 degrees. So this angle and this angle are equal. So meaning angle D is equal to angle B. Reason, or they are equals to 90 degrees. The reason same as this one. Opposite angles of a parallelogram. And then you are done. You get your 3 marks. Nothing difficult. Did you see what did I use? I used all the properties. The first one is to indicate which line is parallel to which one. I've used the opposite angle. So you see, if you didn't know about the opposite and you didn't know about the parallelogram properties, you're going to be in danger. You're leaving like 5 or 6 marks here. So okay, let's move to this one. Is in rectangle ABCD. AB is 3x. It was here 3x. AB, it's 3x. So they've shown us it's 3x. Okay. If you don't read the statement, you're going to miss out some stuff. Imagine if they didn't indicate it here. You see, you will never know what is AB. Okay, and BC it's 4x. You also highlight. You highlight the things they're giving to you. After they're saying determine the length of AC. AC, where is AC? Okay, here's AC. And then they want us to find BD. Where's BD? BD. So since this is a triangle, first let us prove the properties of a rectangle. Number one, we know a rectangle that this side and this side are equal. This one and this one, they are equal. And then the sides, all of them are equal. So these sides are equal, all of them. And then here we have a 90 degrees, we have a 90 degrees, 90 degrees, a 90 degrees. This is what we know so far. Now, they're saying to us, they want us to determine the length of AC, which is the whole of this line. Can you see this line? We want this whole line. And they're saying in terms of x. So meaning that you don't have to solve for x. You can leave the answer with x. So what can we use? If I close here, can you see what's left? It's a triangle. So you can use a theorem of Pythagoras and say AC, which is the one we're looking for, and then squared, and then AB squared plus BC squared. It's going to be AC squared equals to what is this AB? It's 3x and then squared plus what is our BC? It's 4x and then squared. Then we say AC squared equals to what is this? People make mistakes here, so open two brackets if you don't know how to do it. Since I know how to do it with my head, I'm going to write the answer straight away. But if you don't know, do like two brackets so you can see, because someone is going to write 3x squared, which is not correct. It's 9x squared plus 16x squared. It's like this. 4 times 4, 16. X times x, x squared. That is how I got them. Then it's AC squared equals to 9 plus 16. It's going to be 25. So it's 25x squared. Remember, when we want a side, when we want to remove the squared, we square root both sides. And then we say AC equals to, what is the square root of 25? It's 5. And then x. This is our answer. So it's 5x here, our AC. So our AC is 5x. So since we know that this whole line is equal to the whole of this line, that means therefore AC is equals to BD. There's no need for you to do calculations. You don't need to do any calculations, and then you are done. This is your answer. So make sure, guys, that you share the videos and like, comment what you don't understand. I'm still going to post a part 2 for you guys, because I feel like these questions, they're like small questions. So I'll make sure that I post some more. So make sure that you like, comment, subscribe, because you guys don't subscribe. Please subscribe, and then leave a comment there. Nice comment. Don't leave a nasty comment. Yeah, thank you for watching.